All right, so today we're just going to talk about some basic factoring today. And we'll be focusing on mostly factors of numbers, but also some more complicated terms. And again, this is going to help you when you get into something called factoring out of GCF. Did any of you do factoring out of GCF today? I feel like maybe Mrs. Malpass's class was getting into that. All right, well, let me give you some tricks. First of all, do you all have a calculator? You need a calculator today. You're going to be dealing with some bigger numbers. If you don't have a calculator, please grab one now. All right. We want to talk about some shortcuts. When you look at a number, how can you tell if a number is divisible by 2? What's special about every number that's divisible by 2? It's even. Even numbers are divisible by 2. Here's a couple here. Thank you. Can you hand it to him, please? He's in the... Give me an example of a number that's divisible by 2. 34 is divisible by 2 because it's even. All right, do you guys know the trick for telling if a number is divisible by 3? There's a really neat trick for this one. Have you ever heard this one? All right, so check it out. You add the digits. You add the digits, and if the result is divisible by 3, then the whole thing is divisible by 3. So here's an example. 100... Let's do 141. Add those digits up. What is 1 plus 4 plus 1? 6. Is 6 divisible by 3? Then that means that this is divisible by 3. If 6 is divisible by 3, then 141 is divisible by 3. Here's another number. 258. 258. Add those digits up. What's 2 plus 5 plus 8? 15. Is 15 divisible by 3? Yes. Then 258 is also divisible by 3. Here's one more. 335. Add those digits up. What's 3 plus 3 plus 5? 11. Is 11 divisible by 3? Is 11 divisible by 3? Hey, pay attention. Is 11 divisible by 3? Nope. So then this is not either. So this is not, because 11 is not. So add up the digits. If the digits are divisible by 3, then the whole thing is divisible by 3. How about divisible by 5? How can you tell if something's divisible by 5? Yeah, if the last number is a 0 or a 5, then it's divisible by 5. So if the last digit is 0 or 5, then it's divisible by 5. How can you tell if something is divisible by 10? The last digit has to be 0. All right, so we're going to do these things called factor trees and prime factorization. You're going to need to write kind of small on this. So let me show you how this works. We'll do 2 examples together. So we're going to take 24 and we're going to try and split it up into as many factors as we can. And we're going to do prime factors. Prime factors mean the smallest numbers you can multiply together. So here's how we do it. We're going to build a tree off of this. So draw me a couple branches coming off of your 24. I need you to give me 2 numbers that multiply to equal 24. 6 and 4. Now I heard 12 and 2 also. If you want to stick with 12 and 2, that'll work, but I'm going with 6 and 4. All right. Is 6... Can you find 2 numbers that multiply to equal 6 also? What 2 numbers multiply to equal 6? You guys writing this down? Make sure you're getting this down. 2 and 3. What about 2? Is there any way to split up a 2? Yeah, 1 and 2, but we don't ever do 1s because we keep going forever and ever. Is there anything other than 1 that'll multiply to get you a 2? No. So 2 is prime. We're going to circle our prime ones. Those become the fruits on the trees. How about 3? Is 3 prime? What can multiply to equal 3? 1 and 3. Anything other than 1, though? No. So 3 is prime also. What about 4? Is 4 prime? What two things can multiply to equal 4? 2 times 2. So it's not prime. So we'll keep going with 4. 2 and 2. And we already said 2 is prime, so both of those get circled. So there's our tree. We're finished. So to finish up our prime factorization, we're just going to write out all of our factors. And I'm going to go from smallest to largest. So I've got 3 2's, 2 times 2 times 2, and 1 3 times 3. Can you put that away and write this down, please? Thank you. And that's it. That's our prime factorization. If you got your calculator in front of you and you type that into your calculator, 2 times 2 times 2 times 3, see what we get. 2 times 2 times 2 times 3, we get 24, which is the number we started with. So the idea is we're trying to break this down into its smallest prime factors. All right, let's do the same thing for 315. That seems like a bigger number, so it seems like this might take a little bit longer, but a lot of times it doesn't. What number do you know is going to go into 315 based off of our shortcuts up above? 5 has to go into 315 because the last number is a 5, right? So grab your calculator and do 315 divided by 5. What do you get? 63. So let's do 63 and 5 for our first 2 branches. All right, let's focus on that 63 first. I think there's a way we can multiply and get 63. What number do you think goes into 63? 9. I think 9 does. 63 divided by 9 is, yeah, it does. Yeah, 63 divided by 9 is 7. So 9 and 7. Nice. How about 9? 3 times 3, and 3 is prime, correct? So we're done with that branch. How about 7? Just 7 and 1, right? So that's prime. How about 5? Can we split 5 up? What is 5? Just 1 and 5, so it's prime also. All right, so there we go. We got a couple 3's, a 5, and a 7. So 3 times 5 times 7. Now this one also has some x's, so I'm going to put those x's, 1, 2, 3 x's and 2 y's, and we're finished. There's our prime factorization for 315. If I wanted to check this, I could try doing 3 times 3 times 5 times 7. And yes, 315. That's what I wanted to get. You guys get the idea? So we're just taking bigger numbers and splitting them up into smaller factor pairs. Each of these things that multiplies together to equal that 315 is called a factor. If I can get you guys comfortable with this, is going to really help you when you get into factoring later on in chapter 8. So let's spend some time with this. I would like you guys to try, bless you, see if you can finish the next 9 problems here. If you finish early and you go over onto the back, we're going to be doing some more of these. Go ahead and skip the examples, but you could go ahead and do some factor trees with both numbers on the back. That'll be our first step on the back. But let's see if you can finish the first 9 here. Let me know if you guys have any questions. I'll be around to answer questions. All right, wherever you got to on this, I just want you to pause it. If you didn't finish all 9 of these, that's okay. You'll have some more time later on. Actually, I don't even need you to finish the front. The back's the more important part. All right, guys, I don't want you missing this. Some of you guys have already started on this, and that's fine, but you're going to miss the second step of it. So for example 3 here, we're going to start it the same way, But we're going to have to make two different trees. So if you haven't already, go ahead and start making me a tree for 45. And then make me another tree for 75. And I don't know why this is having trouble focusing, but make me a tree for that 45 and then another one for the 75. And let's write out our two factorizations. All right, so I'm going to start with 45. How'd you guys split up 45? 9 and what? 9 and 5. 5 is prime, so we're done there. 9 can split up further into 3 and 3. And I'm going to write that prime factorization down here. 3 times 3 times 5. And then I'm going to do a separate tree for 75. How can we split up 75? 15 and 5? Huh, interesting. All right, 15 and 5. 5 is prime, and 15 we can split into 5 and 3. 5's prime, and so is 3. So 75 is 3 times 5 times 5. All right, I want you to get up to that same point, and then this is the part that I have not shown you yet. So if those who are working ahead, I need you to pay close attention, because I haven't shown you how to find the GCF yet, the greatest common factor. So what we're going to be doing on Tuesday or Monday in our class, and some of you did it maybe today, is factor out a greatest common factor. Our goal today is just to be able to quickly find the greatest common factor for 45 and 75. And here's how we do it. When we have our prime factorization, we just need to pair up like factors. For example, I can pair this 3 and this 3 together. I don't know why I chose these two instead of choosing these two, but it's okay. They match. Do you see something else that matches between both lists of prime factors? What else matches? There's a 5 and a 5 that I can pair up. Now that leaves behind a 3 and a 5. Can I pair those up? No, they're not the same. So my final answer, my GCF, is we got a 3 and we had a 5. So my GCF is 15. 3 times 5 is 15. 15 is the biggest number that goes into 45 and 75. That's what we're trying to find here. All right, let's do another one together. So the first thing we're going to need to do is split up 24 and 48 and find some prime factorization. So 24, help me out. Well, how can I get 24? 6 times 4. Okay, neither of those is prime. 6 is 2 times 3. Martin, are you with us? Yeah. Are you seeing how we're splitting these up into just 2 things at a time? Okay, you fix that? Awesome. 2 and 2 for 4. So there's my 24. I got 2, 2, 2, 3. And I'm going to write out my x's. 1, 2, 3 x's and a y. Sorry, couldn't see that. Now let's do 84. I don't know, 84. What do you guys think? What goes in 84? 2, yeah, 2 goes in 84. It's even, right? You said 42? I'm going to check that. 84 divided by 2. Oops, got to turn it on first. 84 divided by 2 is 42. Okay, agreed. 42 is not prime, though. Let's keep going with 42. Give me 2 numbers to multiply to get 42. 2 and 21. Yeah. And then 21 is 7 and 3. 7's prime, isn't it? Yeah, 7's prime. And 3 is prime. Prime just means it can't split up any further. So what do we got for this one? We got a 2 and a 2 and a 3 and a 7. And then what do we got? 2 x's, 2 y's, and 2 z's. All right, let's see what we can match up this time around. We're going to start building our GCF now. Pausing to make sure everybody's on the same page. All right, what do you see that we can pair up? I see some 2's, so I got 1, 2. I see another pair of 2's, so I got 2 2's. Pair of 3's, so I got a 3. What else do you see? X's, how many pairs of X's? 2 pairs of X's. Any Y's? How many pairs of Y's? Just 1 pair of Y's. Any Z's? No Z's? All right, so our final answer, our final GCF greatest common factor is 2 times 2 times 3. Let's see if we can pull that off in our head. 2 times 2 is 4, times 3 is 12. 12, and then we got 2 x's, x squared, and a y. So 12x squared y is our GCF here. That's the big process, okay? So my challenge to you, I would not worry about the front side. If you can do this back side, this is the important piece. See if you can get that back side done, and let me know if you have questions. Once you're finished with this, feel free to move on and work on assignments. If you think you're done with every single assignment, let me know. I'll check your Skyward and see if I agree with you. All right, guys, get after it. Let me know if you need any help. We'll zoom this out so you can see all. And I'll put answers up here in a moment so you can check.